Atomic models. The concept of the atom originated around 400 BC with the Greek philosophers Leucippus and Democritus. They imagined an indivisible object whose properties depended on its macroscopic physical properties. For example, water atoms would be slippery and earth atoms would be solid and hard. It wasn't until 1802 when the chemist John Dalton proposed that elements were made up of indivisible atoms that could not be altered by chemical means and could combine with each other in integer ratios. Models of the structure of the atom evolved rapidly once Thomson discovered the electron. Thomson's discovery of the electron was the first evidence that the atom had an underlying structure. In 1904, he proposed that electrons moved about within a mass of positive charge. He never really said what that positive charge was. Thomson's model for the atom was called the Plum pudding model, since the electrons are distributed throughout some positively charged stuff, much like the English dessert, where raisins are embedded in an egg, suet, and molasses mixture. The Rutherford Model. The Plum pudding model only lasted 5 years, until work done by one of Thomson's former students, Ernest Rutherford, along with Hans Geiger and Ernest Marsden. Their experiment fired a beam of alpha particles at gold foil. If the atom was like a plum pudding, the alpha particles would go straight through. But the alpha particles didn't go straight through. The experiment found that some of the alpha particles were deflected. Some bounced back towards the alpha source. And as Rutherford said, it was quite the most incredible event that has happened in my life. It was almost as if you fired a 15-inch shell at a piece of tissue paper and it came back and hit you. The conclusion? The positive charge was located in a tiny region of the atom, which ended up being called the nucleus. Since the results of Rutherford's experiments showed that all the positive charge of the atoms was concentrated in a small region, the nucleus, most of the atom was just empty space. Consequently, most of the positively charged alpha particles would not be deflected by the positively charged nuclei. However, the small percentage of alpha particles that actually did strike a nucleus were deflected, and in the most extreme case, they've bounced straight back at the source. After analyzing the data, Rutherford proposed that atoms consist of a nucleus with a diameter of the order of 10 to the minus 15 meters, 1/100,000th the diameter of the atom, and that nucleus was surrounded by electrons in planetary orbits. Well, why do you think Rutherford proposed planetary orbits? Well, the planetary orbit model was probably chosen because of the similarities between the force equations for gravity and that of the electric force. These are shown just below. You're familiar with both of these. Since the equations are similar, that is, they are inverse square laws and depend on products of properties of the objects, and gravity causes planets to move in an orbit around the sun, why wouldn't electrons do the same relative to the nucleus? Well, Rutherford didn't propose how the electrons orbited. That was left to Niels Bohr. Well, before we move on, it's important to emphasize just how much of the atom is empty space. If the nucleus was magnified so that it was the size of a baseball, then the atom would have to have a radius of 4 kilometers. The electrons would be the size of the period at the end of this sentence. Here's a website that you can have a look at that provides a great simulation of Rutherford's gold foil experiment.